Alright, good morning class. Okay, we are into 6.4. Okay, yesterday we had logarithmic equations of different bases and you managed to actually solve those equations. So now we want to also solve another kind of equation, the exponential equations using logarithm. Alright, now previously in 6.1 we had exponential equations where we can actually convert them to the common base. Right, for instance, this example where you can convert to base 2, alright, and then you solve it. Now, what about those equations which we cannot convert to common base, like 3 power x equals to 17. So we can't convert to the same base, we would need to use logarithm. Okay, so let's look at example 1. Okay, solve 5 to the power y plus 2 equals to 7. So there is no way we can convert 5 and 7 to the same base. Okay, these two are prime numbers anyway, right? Okay, so we have, we will take, okay, LG on both sides, and then we apply your power law, okay. So this would be 5 plus 2 LG 5 equals to LG 7, okay. So y plus 2 is equals to LG 7 divided by LG 5, and y equals to LG 7 over LG 5 minus 2. So you would ask, why is it that we take LG instead of LOG to any other base? Okay, that's because the calculator, when they say LOG on your calculator, is actually base 10. Okay, it's not any other base, it's actually base 10. Okay, so you will have negative 0.79093, right? So 3SF, negative 0.791. Okay, 3SF. Okay, done. Okay, the next one. Okay, 6 to the power x plus 2 equals to 21. Again, 6 and 21, there is no common base. You cannot divide by 3 either. Okay, so this you will have to take LG. So LG 6 power x point plus 2 equals to LG 21. So again, okay, power law, bring the power to the front. Okay, so you will have 6 plus 2, okay, LG 6 equals to LG 21. Okay, so x plus 2 is equals to LG 21 divided by LG 6. So x is equals to LG 21 over LG 6. So you leave the calculator value to the end. Okay, you don't have to calculate out the value here first until the end is neater. So it's LG 21 divided by LG 6. Okay, and then minus 2. So you get negative 0.30081 dot dot. So this is negative 0.301, correct to 3 significant figures. Okay? Okay, alright, further examples, e to the power 3x is equals to 9. So again, there is no common base between e and 9. By the way, e is actually your Euler's number. Okay, 2.71828182 and so on, yeah? It's a special constant, very much like pi. Okay, so in order for you to solve this, you will have to take ln on both sides. So ln of e to the power 3x is equals to ln 9. Okay, then you bring this to the front. So I have 3x ln e equals to ln 9. Okay, so ln e, okay, so ln e will be equals to 1. Why is that so? Because ln is log base e. So log base e of e is equals to 1. Okay, just like your LG, yeah? Log base 10 of 10 is equals to 1. So LG 10 is also equals to 1. Okay, so these are your special values. So in this case, your ln e is 1, right? So therefore you will have 3x equals to ln 9. So x is equals to ln 9 divided by 3. Okay, so 3SF, so ln 9 divided by 3. Ln 9, your calculator has ln divided by 3. Okay, 0.7324 dot dot dot. Okay, so your final answer is equals to 0.732 3SF. Okay, so similarly here, okay, you have e to the power 3x minus 1 equals to 8, right? So you take ln on both sides, so ln e to the power 3x minus 1 equals to ln 8. Okay, then you apply your power law, you bring this to the front. Okay, so you will have 3x minus 1 ln e equals to ln 8. Okay, so ln e is 1, so ln e is 1, so it's 3x minus 1 equals to ln 8. So don't use a calculator here yet. So 3x is equals to ln 8 plus 1. So x is equals to ln 8 plus 1 divided by 3. So final step, then you press the calculator. So ln 8, okay, plus 1, and then divide by 3. You should get 1.0264 so it's 1.03 correct to 3SF. Okay, so quite easily done. Alright, so we move on to the next one. Okay, so far so good. Okay, solve 3 to the power x times 2 to the power 2x equals to 7 times 5 to the power x. So example 2. Okay, so the bases are different, right, class? So can we therefore try and do something about the powers? Okay, so let's see. Okay, 3 to the power x. Okay, 2 to the power 2x actually is 4 to the power x, right? So this is equals to 7. 5 to the power x. Okay? So, okay, your law of indices. Okay, you have a to the power n times b to the power n is equals to a times b to the power n. Isn't it? For example, you have 3 square times 2 square is actually 3 times 2 all square, which is 6 square, which is correct. Okay, 9 times 4 is 36. Okay, so in this case, you can therefore put common power is x here. So this is 3 times 4. Okay, this is 7 times 5 to the power x. So I have 12 to the power x equals to 7 times 5 to the power x. Okay, then 12 to the power x over 5 to the power x is equals to 7. Okay, that means 12 over 5 power x is equals to 7. Okay, so once you come to this step, it will be easy. Okay, so this becomes your basic exponential equation, right? So this is in the form a to the power x equals to b, right? Correct or not? So you can actually take LG on both sides. So you LG on both sides, LG, right? Okay, and then LG 7. Okay, so you LG on both sides. Can? And then you bring the power to the front. So you have x LG 12 over 5 equals to LG 7. So x is LG 7 over LG 12 over 5. Okay, so use a calculator. LG 7 divide by LG 12 over 5. Okay, you should get 2.22. Okay, 2.22. 2.2227. So it's 2.2227. So it's 2.22 correct to 3 significant figures. Okay? Okay, so you try to solve on your own. Alright? So there are 4 sums. Okay, so take some time to try and see what you can do. And then you pause the video later on after you have solved it. Then you play and see whether you've got the correct answer. Hang on, let me change the ln 3. Okay, ln 3 is actually 1 point something. 1.0986 So it's 1.10. Okay, 3SF. Yeah, so can you check and see whether you have got them correct? Yeah. Okay, any questions? Please let me know. Okay. Okay, so we are halfway through our video. Okay, this is a rather short one. So, okay, simultaneous equations. Okay, not the first time that you have encountered this. Okay, so equation 1. Okay, your equation 1 log base 4 x minus 2y equals to 0. Alright, so convert this to linear. So your base here, okay, the first one, so the base is 4, right? So 4 to the power 0 is equals to x minus 2y. So x minus 2y is equals to 1. Okay, so x is equals to 1 plus 2y. Okay, so that's one equation. Okay, this will come in handy for the second equation. Okay, second equation is log of x minus 1 equals to 2 log of y, LGY. Okay, so it's LG x minus y equals to LG y square. So therefore, x minus 1 is equals to y square. This is equation 2. So substitute equation 1 into equation 2. So you will have 1 plus 2y equals to, 1 plus 2y minus, minus 1 equals to y square. Okay, so y square minus 2y is equals to 0. So y into y minus 2 is equals to 0. So either y is equals to 0 or y equals to 2. Okay, 2 solution. Alright, can y be 0? Okay, y cannot be 0. Why? Why is y not 0? Right, because this is rejected straight away. Yeah? Why? Because 2 LGY is equals to 2 LG0 is undefined. 10 to the power of what gives you 0? There's no answer. Okay, no answer. Okay, so that means y equals to 2. So y equals to 2, therefore, right, x will be equals to 1 plus 2 times 2. So x is equals to 5. So your solution, final solution, x is equals to 5, y is equals to 2. Okay? Alright class, the last example. Okay, so log base 3, right? So base 3, so you convert it. Okay, the first one, 3 to the power of 2 is equals to 3x minus y plus 5. So 3x minus y plus 5 is equals to 9, right? So, okay, y is equals to 3x minus 4. Okay, so leave it first. Okay, the other equation, okay, ln of 11 minus y minus ln x is equals to ln 2. Okay, so in this case, how do you simplify? You use your quotient rule. Okay, the difference of 2 ln. Okay, your laws of logarithm applies to ln as well, because ln is also part of log, isn't it? It's just that the base is e. Okay, so your quotient law will say that this will be ln of 11 minus y over x, ln of a quotient. Okay, so this is equals to ln 2. So both sides you have ln, right, which means that 11 minus y over x is equals to 2. So 11 minus y is equals to 2x. Okay, so this is equation 1, right? So you substitute equation 1, right, into equation 2. So this is equation 2. Okay, so you will have 11 minus 3x minus 4 is equals to 2x. So 11 minus 3x plus 4 is equals to 2x. Okay, so 5x is equals to 15. So x is equals to 3. And therefore, y is equals to 3 times 3 minus 4. That is 5. Okay, so your final solution, x equals to 3 and y is equals to 5. Okay, finally, just a note. Okay, simplifying exponential expression containing logarithm in its index. So which means that now your power can be LG as well. So you look at A, 10 to the power LG7. Okay. So if you were to press your calculator, okay, the answer will be 7. Okay, if you press like 10 to the power of LG2, okay, your answer is 2. Right, your answer is 2. So similarly, if you have E to the power ln 5, if you press a calculator, okay, E to the power ln 5, your answer will be 5. Or E to the power ln 7, your answer is 7. Okay? Alright, pretty much, okay, like, okay, ln E to the power 7. Okay? Right? And also, of course, it's like LG 10 of 2 is equals to 2. Okay, because your ln and your e, they cancel, they neutralize each other. Okay, they are the inverse of each other. Okay, so ln e to the power 7 is 7, e to the power ln 7 is 7. Okay, so those are the special identity that you need to know. Okay, it may come in handy when you're trying to solve certain sums. Okay, so that's a short video for you for today. So your homework will be textbook page 125, exercise 60. Okay, all the sum. Okay, please check your answers. Okay, when you send in your file to me in WhatsApp group, okay, make sure that it's PDF form, and then perhaps you can help by naming your file. Okay, put your name in front in capital letter. For example, Naveen AM means AMAth, worksheet 9, exercise 60, or Cheryl AM, worksheet 9, exercise 60. Okay, so try to do that, yeah? Okay, when do you hand in your work? Today, 15 April. Okay, 10 p.m. Okay, try to do as much as you can, because for this, okay, you need to keep up with the daily exercise. Then that will help you to build up your foundation. Is that alright? Thank you, everyone. Have a good day.